projects. In this video, we will explain about the project, which is heart disease prediction using novel Quine McCluskey binary classifier, which is QMBC. Introduction of the project. The project focuses on heart disease, encompassing various pathological disorders affecting the heart and blood vessels, including vascular diseases and disturbances in the heart rhythm. Highlighting the gravity of the issue, the World Health Organization, which is WHO, identifies HD, which is heart disease, as the deadliest and most devastating disease, claiming over 18 million lives annually. This underscores the urgent need for effective diagnostic tools and methods. Traditional diagnostic methods involve assessing a patient's medical history, blood pressure, blood sugar, and cholesterol. Advanced medical procedures such as electrocardiograms, X-rays, and imaging techniques like MRI and CT scans play a crucial role in identifying cardiac conditions. The project emphasizes heart failure as a consequence of chronic issues that weaken the heart muscles, potentially impacting vital organs. It outlines primary risk factors including age, ethnicity, family history, lifestyle choices, and pre existing cardiovascular disease or genetics. To enhance early diagnosis, the project introduces the integration of machine learning techniques to explore the use of ensemble methods, particularly the novel Quine McCluskey binary classifier, which is QMBC, to predict patients diagnosed or not diagnosed with heart disease. The effectiveness of the proposed approach is evaluated against benchmark datasets showcasing superior performance compared to existing models in the terms of accuracy, precision, recall, and FN score. Objective of the project is the primary objective is to address the global health challenge of cardiovascular disease, which is responsible for a significant portion of worldwide mortality, by developing an efficient predictive model for timely patient identification and diagnosis. Introducing a novel ensemble approach, the Quine McCluskey binary classifier utilizing a combination of 7 machine learning models. The goal is to enhance predictive accuracy for binary classification of patients diagnosed with heart disease and those without. The aim is to utilize advanced feature selection and extraction techniques, specifically chi-square and ANOVA, to identify the most relevant features and create a streamlined subset of dataset to the dataset, focusing on the most informative components. The project aims to import and explore and process heart disease dataset including Cleveland HD, HD Comprehensive, and CVD using Pandas data frames. The primary objective is to build a comprehensive set of machine learning models including logistic regression, decision tree, random forest, KNN, naive Bayes, support vector classifier, MLP, voting classifier, and a novel Quine McCluskey binary classifier. The models are trained using the feature selected datasets obtained through ANOVA FS, chi-square feature selection, and the original dataset. To implement the project, we need software and hardware requirements. Coming to software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, front-end technologies of HTML, CSS, JavaScript, and Bootstrap 4. And the hardware requirements are operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. To implement the project, we have designed various steps in the flow of work. The first step is importing the packages. This step involves importing necessary Python libraries and packages that will be used throughout the project. We have imported NumPy for numerical operations, Pandas for data manipulation, Matplotlib and Seaborn for various visualizations, scikit-learn for machine learning, and Flask for web development. The next step is exploring the dataset. Here, 3 hard disease datasets, which are Cleveland HD, HD Comprehensive, and CVD, are explored to understand their structure, features, and contents. This exploration includes checking for missing values and data types and general statistics. Data processing. Here we converted data into Pandas data frames for data manipulation. We dropped unwanted columns, which involves removing any irrelevant or redundant features from the datasets that won't contribute to the analysis or model training. We do component analysis for understanding the data. Coming to the next step, which is visualization using Seaborn and Matplotlib. This step involves creating visualizations to better understand the data. Seaborn and Matplotlib are the popular Python libraries which are used for creating plots such as histograms, scatter plots, and bar charts. Visualization helps in identifying patterns, trends, and potential outliers in the data. Label encoding using label encoder. In machine learning, many algorithms require numerical input, and label encoding is a technique to convert categorical variables into numerical form. The label encoder assigns a unique numerical label to each category. The next step is feature selection. Feature selection aims to choose the most relevant features for model training, improving model performance and reducing computation time. Here we have used a technique which is ANOVA FS, analysis of variance feature selection. It is a statistical technique used for feature selection. It assesses the variance between two groups within groups in a dataset to identify features that exhibit significant differences among classes. In the context of machine learning, ANOVA FS helps selecting features that contribute the most variation between different categories or classes, making it particularly useful for classification tasks. The next step is chi-square feature selection. Here, chi-square feature selection is another statistical method for feature selection, specifically designed for categorical input and categorical output variables. It calculates the chi-square statistic for each feature, indicating the independence of the feature from the target variable. Features with high chi-square statistics are considered more relevant and they are retained, while less informative features are discarded. These are the two statistical methods, which are chi-square FS and ANOVA FS, based on analysis of variance and chi-square test respectively. Original refers to using the dataset as it is without feature selection. The next step is splitting the data into X and Y. This step involves separating the dataset into features as X and the target variable as Y. Features are the input variables used to make the predictions, while target variable is what the model wants to predict. The next step is building the model. This step involves defining the machine learning models that will be used in the project. Coming to the next step, which is training the model. The models are trained using the training dataset. Training involves adjusting the model parameters to learn patterns and relationships within the data. The next step is Flask framework with SQLite for sign up and sign in. This step involves setting up a web application using Flask, a web framework for Python. SQLite is a lightweight relational database is used for user authentication, allowing users to sign up and sign in. The next step is user gives input as feature values. User provide input, which are the feature values relevant for predicting heart disease through the front end of the web application. The next step is given input is pre-processed for prediction. The user input is pre-processed to ensure it aligns with the format expected by the trained machine learning models. This include handling missing values, encoding categorical variables, and scaling numerical features. Trained model is used for prediction. The pre-processed input is fed into the trained machine learning models to make predictions about the likelihood of heart disease based on the provided features. Final outcome is displayed through frontend. The predictions made by the models are displayed to the user through the frontend of the web application, providing a final outcome based on input features. This outcome indicates the probability and the likelihood of the user having the heart disease. Algorithms which are used in the project are logistic regression. Logistic regression is a statistical method used for binary classification problems. It models the probability of an instance belonging to a particular class. Despite its name, it is used for classification rather than regression. It works well when the relationship between the features and the target variable is approximately linear. Logistic regression is commonly used for binary classification tasks, making it suitable for predicting whether a patient is diagnosed with heart disease or not. Decision tree is a tree-like model where each internal node represents a decision based on the value of a particular feature, and each leaf node represents the predicted outcome. It is a versatile algorithm capable of handling both classification and regression tasks. Decision trees are employed for their interpretability and ability to capture complex decision boundaries, making them suitable for predicting heart disease based on various features. Random forest. It is an ensemble learning method that constructs a multitude of decision trees at training time and outputs the class that is mode of classes, which is classification of individual trees. Random forest is chosen for its ability to reduce overfitting and improve model generalization. It aggregates predictions from multiple decision trees, enhancing the overall accuracy and robustness of the model. KNN, which is K nearest neighbor, it is a simple and effective classification algorithm that classifies an instance based on the majority class of its K nearest neighbors. It is non-parametric, lazy learning algorithm. It is selected for its simplicity and effectiveness in capturing local patterns in the data, and it is particularly useful when there are clear clusters or the patterns in feature space. The next algorithm is naive Bayes. It is a probabilistic classification algorithm based on Bayes' theorem. It assumes that features are conditionally independent given the class, hence the term is naive. Naive Bayes is chosen for its simplicity and effectiveness in handling high dimensional data. It is effective when the assumption of feature independent holds reasonably well. The next algorithm is support vector classifier, which is SVC. It is also known as support vector machine for classification. It is a powerful algorithm that finds the hyperplane that best separates classes in high dimensional space. It is employed when the data has complex decision boundaries, and it is effective in capturing intricate patterns and relationships within the feature space. The next algorithm is MLP, which is multi-layer perceptron. It is a type of artificial neural network composed for multi-layers of nodes, which are neurons, including an input layer, one or more hidden layers, and an output layer. MLP is chosen for its ability to model complex relationships in the data. Neural networks, including MLP, are powerful for tasks where the relationships between features are highly non-linear. Coming to QMBC, which is Quine MC Binary Classifier. QMBC is a novel ensemble technique introduced in the project. It aggregates predictions from 7 individual models using Quine MC Klasky method to obtain minimum Boolean expression for the target feature. It is a custom ensemble technique designed specifically for this project. Its effectiveness is demonstrated by surpassing state-of-the-art models in accuracy. It combines the strengths of different algorithms to enhance predictive performance. As an extension, we employed ensemble models combining the prediction of individual models to improve the accuracy and for final prediction. Also, as an extension, we built Flash framework for user testing with the user authentication. We have used accuracy, precision, recall, and FN score, which are the performance metrics to evaluate the project. So here we have the performance comparison graphs for the dataset, which is Cleveland HD dataset. This is accuracy comparison graph where x-axis represents accuracy score for each algorithm and y-axis represents algorithm names. Similarly, we will have for other graphs also. Accuracy is the measure of the overall correctness of the model. It calculates the ratio of correctly predicted instances to the total number of instances. This is precision score comparison graph. It is the ratio of correctly predicted positive observations to the total predicted positives. It evaluates the accuracy of positive predictions. This is recall comparison graph. Recall is also known as sensitivity or true positive rate. It measures the ability of the model to capture all relevant instances. It is the ratio of correctly predicted positive observations to the total actual positives. This is FN score comparison graph. It is the harmonic mean of precision and recall. It provides a balance between precision and recall, and it is especially used when there is an imbalance in the class distribution. Here we have the same performance comparison graphs for the dataset, but these are the models built for the feature selection technique, which is ANOVA. And this is for feature selection technique, which is chi-square feature selection. Here we have performance comparison graphs for the dataset, which is comprehensive HD. And this is for ANOVA feature selection for the same dataset. This is for chi-square feature selection for the same dataset. And here we have performance comparison graphs for the CVD dataset. Here for ANOVA feature selection technique, this is for chi-square feature selection technique. The algorithm which performs well among all these metrics will be used for final prediction. To execute the project, first we need to open the code folder which contains source code. This is the code folder of the project. This is the dataset folder in which we have all the 3 datasets. We use all the 3 datasets for training the algorithms. This is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is the app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in the HTML templates. These are the model files which contain the algorithm information and that will be loaded into the project code during runtime. And these are the IPYNB files. These are the Jupyter Notebook files which contain a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. This is the sign up file. This file is the database file used to store the user information. Now we have to copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now we need to open the Anaconda prompt. Using the cd command followed by the space, we need to paste the copied path and then click on enter. Here, current directory is changed to the code folder's path. Here we need to type the command python space app.py and then click on enter. This will compile app.py file and it will execute Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port unless configured differently. This is the local host and this is the port. Now we need to copy this local link provided by the framework and paste it in any web browser. So I'm copying the link. I prefer Google Chrome, so I'll paste it in that. Here we need to paste the link and then click on enter. This is the web page of the project, which is displayed in the browser, and this web page is built by using the Flask framework. Here we can see a sign up link. We need to click on that. Here we need to enter all the sign up details if we are signing up newly. I have already signed up and have an account in it, so we'll directly log in. For that, here we need to click on login. And here we need to provide our credentials, which are the username and the password. So I'm giving my username and the password to login. And now click on login. We have logged in successfully and we are redirected to prediction page. Now we will do the prediction for all the three data sets. First, we will do the prediction for the Cleveland dataset. For that, under prediction, click on Cleveland. Here we can see the parameters which are need to be entered. Based on the given parameters, we will get the prediction whether heart disease is detected or not. Prior entering parameters, we will understand them. Here we have age, which is the age of an individual person. The next one is rest BPS, which is resting blood pressure. Resting blood pressure is mmHg, a key cardiovascular health indicator. The next one is call, which is serum cholesterol. It is the level in mg by dl assessing heart disease risk. The next one is talaj, which is maximum heart rate achieved. Coming to exang, it is exercise-induced angina, which is a binary parameter indicating the presence or absence of exercise-induced angina. Coming to old peak is ST depression induced by exercise relative to rest. ST depression on ECG during exercise reflecting microcardial ischemia severity. The next one is CA, which is number of major vessels colored by fluoroscopy. These are the number of blood vessels colored by fluoroscopy indicating potential coronary artery disease. The last one is TAL, which is thalassemia. It is a categorical variable representing thalassemia type, a genetic factor with implications for health. Now we will enter all these parameters. So the age of the person is 45. Test BPS value is 112. Cholesterol is 160. Maximum heart rate achieved, which is Talach, is 138. Exang is 0. Old peak value is also 0. CA value is 0. TAL value is also 0. Now we will click on predict. Here we got the prediction as the patient is not diagnosed with heart disease. Now we will enter other patient's parameters. For that, under prediction, click on Cleveland. Age is 52. Trust BPS is 112. Cholesterol is 230. Talach value is 160. Exang is 0. Old peak is 0. CA value is 1. TAL is 0. Now click on predict. Here we got the prediction as the patient is diagnosed with heart disease. Now we will do the prediction for the dataset, which is HD comprehensive. Here also we have the parameters which are need to be entered. So first we will understand them. Similarly, we have age of the person, chest pain type. It is a categorical variable indicating the type of chest pain experienced by individual. The next one is resting BPS, which is resting blood pressure. Resting blood pressure is mmHg, a crucial indicator of cardiovascular health. Next one is cholesterol, maximum heart rate. excise angina, old peak value, and the last one is slope, ST slope. ST slope is categorical variable representing the slope of the ST segment during exercise on ECG feature related to heart function. Now we will enter all these parameters. I entered all the parameters. Now we will click on predict. Here we got the prediction as the patient is diagnosed with heart disease. Now we will enter other patient's parameters. For that, under prediction, click on HD comprehensive. I entered all the parameters. Now click on predict. Here we got the prediction as the patient is not diagnosed with heart disease, which means patient is not being affected with the heart disease. Now we will do the prediction for the other dataset, which is cardio. For that, under prediction, click on cardio. Here we have the parameters. This is the age of the person, weight of the person. The next one is APHL, which is systolic blood pressure. The systolic blood pressure, the higher value in blood pressure measurement, which is mmHg, indicating pressure during heartbeats. Next one is APLO, which is diagnostic blood pressure. The diastolic blood pressure, the lower value in the blood pressure measures mmHg, indicating pressure between heartbeats. The next one is cholesterol. Next one is glucose. Glucose is the blood glucose level, a parameter relevant to diabetes and overall health. The next one is smoke, which is the person is having smoking habit or not. The last one is active. It is a binary variable indicating whether the individual engages in regular physical activity. Now we will enter all these parameters. I entered all the parameters. Now we will click on predict. So here we got the prediction as the patient is not diagnosed with heart disease, no CVD, which means cardiovascular disease. So person is not having cardiovascular disease. Now we will enter other patient details. For that, under prediction, click on cardio. I have entered all the parameters. Now click on predict. Here we got the prediction as the patient is diagnosed with heart disease and is having CVD. Now click on sign out. In this way, if we enter the parameters of the patient based on the given parameters, we will get the prediction whether patient is diagnosed with heart disease or not. So the conclusion of the project is the project utilized advanced feature selection techniques such as ANOVA feature selection and chi-square feature selection along with the consideration of the original dataset. This comprehensive approach ensured that the most relevant features were identified, contributing to the improved efficiency and performance of the machine learning models. By incorporating a diverse set of machine learning algorithms, including logistic regression, decision tree, random forest, KNN, naive Bayes, SVC, MLP, and QMBC, the project aimed to capture a wide range of patterns and relationships within the heart disease datasets. This diverse model set contributed to a more robust predictive model. The inclusion of Flask framework with SQLite for sign-up and sign-in enhanced the project's practical utility. The integration allowed users to interact with the predictive model through user-friendly front-end, making the application accessible and user-tested. The project identified possibilities for future enhancements, such as exploring additional ensemble techniques. Moreover, there is potential to achieve high accuracy. The extension of the project to include user authentication and front-end development using Flask provides a foundation for further usability and testing improvements. The project's predictive model and user-friendly web application provide a valuable tool for healthcare professionals, patients, researchers, public health authorities, software developers, and the general population, contributing to early detection of heart disease, informed decision-making, research advancements, improved public health strategies, and accessible healthcare technology.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.